Hey, what's up guys, my name is Cherno. Welcome back to my C++ series. We're back at it again with those bitwise operators. So last time we had a bit of an introduction to binary in general, and we took a look at the bit shift left and the bit shift right operators. If you haven't seen that video, I highly recommend you watch it because we're basically continuing on from that video here today. Now, I'm not going to spend any time today recapping what we did last time. We'll talk about binary and bits in general, so we can jump right into the rest of the bitwise operators that we need to talk about, which are the bitwise AND, the bitwise OR, the bitwise exclusive OR or XOR, XOR, and finally the bitwise NOT operator, the squiggly line kind of inversion thing. Bitwise invert. That's what I call it. So the plan for today is basically to take a look at those operators and just like break down exactly what it is they do. And then in the next video, the final video of this little series, we're actually going to take a look at some real world examples in which all of these operators get used so that you can kind of put together why they might be used in the first place. Because I understand that that's probably one of the biggest questions people have who are introduced to these operators and are like, but why do they even exist? Why do I need them? So before we jump in and start drawing stuff on this little amazing tablet that I have here, this video is sponsored by Skillshare. Now, for those of you who don't know, Skillshare is an amazing online learning community where millions of creative and curious people from all around the world come together to learn any number of amazing new skills that are taught extremely professionally in bite-sized videos on just a whole wide variety of topics. The great thing about Skillshare that I think separates it from other kind of similar platforms are that the videos are so kind of concise that then they don't just go on for hours. I mean, other websites that have courses might have a course that goes for like 60 hours, and that's all fine, but sometimes you just don't have the time and you don't want something that goes into that level of depth. You just want like a nice, solid, concise overview that will kind of explain as much as possible about that topic, but be kind of easier to consume in kind of shorter videos that you might have time to catch here and there after your busy life at work. And that, I think, is where Skillshare really shines, and that's why I've been appreciating it lately so much. Whether you want to learn about creative topics such as photography, videography, illustration, art, that kind of stuff, or the more business side of things, or maybe productivity, Skillshare literally has courses on pretty much anything you can think of. Coming in at just under $10 a month for an annual subscription, Skillshare is an amazingly affordable way to add some more learning into your life and learn some new skills. Skillshare are offering the first 1,000 people who click the link in the description below a free trial of Skillshare Premium. So go ahead and do that. Check it out for free, see what amazing courses are available out there, and learn some new skills. Huge thank you to Skillshare, as always, for sponsoring this video. And now let's take a look at the rest of the bitwise operators. Okay, so what you're looking at over here are all of the bitwise operators. These two we have already covered in the previous episodes, so we don't need to talk about them today. And today is going to be about the rest of these. So we have the bitwise AND, the bitwise OR, the bitwise XOR or exclusive OR, and then the bitwise NOT operator. Now, three of these three, they act on two different variables or two different bit patterns, really. So in other words, it's always like A and B, or A or B, or A XOR B. You need two values to actually be able to use these operators. However, the NOT operator is a unary operator, meaning that it actually acts on a single variable. So in other words, you wouldn't do A not B, that doesn't make any sense. Instead, you would use it with a single value like that. All right, so without further ado, let's get started and start by talking about this AND operator over here. Now, the AND operator is actually very similar to our logical AND. Logical AND is basically when we use a double ampersand like this, and a bitwise AND, we use a single ampersand. A lot of people are confused about the difference because in a lot of cases, this seems to almost work the same way as the logical AND. However, they are very different things. This is, of course, a logical AND meant to compare two kind of Boolean values, whereas this is an actual bitwise operator. So what does it do, and why am I saying that it's similar to a logical AND? It compares two bits, such as 0 and 1, and it will return a 1 if both of those bits are 1, otherwise it will return a 0. So if you kind of flip this into a logical statement, if we have something like false and true, then we would expect to get false in this case. And in fact, I don't know why I wrote a 1 there. It's clearly 0. But my point is that if you treat the zeros as false and the 1s as true, which is effectively what they are, then this works in exactly the same way as this kind of logical AND. Both sides of this equation have to be true in order for this to be true, because you're effectively saying, is this true and is this true? And if so, then of course the result is true. One thing I didn't point out, by the way, is in comparison to these bit shift left and right operators, which obviously take some kind of variable on the left side and then you shift that by like X amount of places, either left or right, this actually acts on 2-bit patterns. So this is simply a number in the shift operator to actually shift by, whereas these are specifically meant for being used with 2 variables, and the bits of those variables are the things in question here. Okay, so let's get back to our little example here. Let's kind of expand on this so that maybe it makes more sense if you're still not sure about how it works. So I'll write a little table here. So 0 and 0 will give us 0 because neither of them are true. 0 and 1 will give us 0 because, well, they both have to be true, or they both have to be 1 in order for us to get a 1. 1 and 0 will also give us a 0 because, again, they're not both 1. And finally, 1 and 1, of course, will give us 1 because they're both 1. Now, of course, in this case, we were just comparing one bit with another single bit. If we expand this out into some kind of number like this, and we compare it like that, I'm not sure what I'm writing here, then we simply have to do this to each bit, of course. So this will give us 0, 1, 0, 1, because only in these 2 cases are they both 1. In this case, they're both 0. We don't care about that. That is still 0. And then in this case, one of them's 1, but they both have to be 1 for us to actually get a 1. So this is the result that we are left with. Now, what can we actually do with this information in practice? Well, this bitwise AND is actually very commonly referred to as a bit mask. In fact, you can use it to mask out selective bits. What on earth do I mean by that? Well, if we have some random number, and I'll express it in binary here. Let's just say 1, 0, 1, 1, 0, 0, 1, 0, 1, whatever. If I am interested in checking the state of a single bit here, I can actually do that using the bitwise AND operator. So for example, if I'm interested in knowing the state of this bit over here, so that's 0, 1, 2, 3, 4, 5, the 5th bit we'll say, from this right side over here, all I need to do is construct another value here, another number that will act as a mask that I can use to select this bit and then see what its value is. So how do we build this mask? Well, what do we know about this AND operator? We know that only in the case of both of these values being 1 do we get a 1. In every other case, we get 0. So what we can do is actually fill this second number here, the number that will be ANDing that first variable we care about with, we can fill it with zeros except for the spot where the bit we're interested in lies. So in other words, over here, I'll put a 1. Everywhere else, we just simply put a 0. And when I AND these two values together, well, you can already see what this is going to end up with. There's zeros everywhere. So we know that all of the places that have zeros, no matter what the other number is, will also get 0. It doesn't matter what the other bits are, we'll always get 0 if this side is 0. However, in this kind of place, with this bit that we are interested in, we're going to get a 1 in this case because it's set to 1 and 1 and 1 is 1. Or if it had been 0, well, what would we get? 0. So now we can very easily check the state of that particular bit. Because even though it happens to be all the way over here, this variable here, our resulting variable, is really only going to be one of 2 states. Either completely 0, because, well, it returns 0 and the whole number is 0, or something else. So, or greater than 0, right? In this case, we have 0, 1, 2, 3, 4, 5. 2 to the power of 5 is 32. So this value would actually give us 32. So I'll just kind of write that in here. But of course, if it had been 0, then it would have given us 0. And so what we can do with this value is we can, for example, pass the result, this little bitwise result, into an if statement like so. And obviously, if it's not 0, so 32, for example, it's going to be true. And we can act accordingly. However, if it is 0, then it's going to be false and we don't go into that branch. And that's actually a very common use case of this bitwise AND operator because the value doesn't have to be 1 for this to be true. Any value other than 0 in a Boolean sense is going to be true, even a negative value. If there's any data present aside from 0, then it's true. And of course, this masking situation works for other use cases, not just checking the state of a single bit. So for example, what I could use it for is to literally select a whole group of bits or clear a group of bits. So for example, if I take that same number that I had over here and I pop it here, if I want to just isolate this group over here, or maybe I want to clear this to 0, then all I have to do is AND this with 0, 0, 0, 0, 0, and then 1, 1, 1, 1. And that will, of course, give me 0, 0, 0, 0, 0. And then for this side over here, it will give me 0101, which coincidentally is exactly the value we started with. So what I've done is I've effectively removed this whole bunch of bits. They're irrelevant. I'm just focusing on my little selection here. So this bitwise AND operator we can use to mask out or select specific bits. Okay, so what about the OR operator? Well, the OR operator works much the same way. And again, this is similar to a logical OR. I'll try to make these longer so you can tell that they're not ones. If either of them are true, then the result is true. So if either of these are 1, we'll get a 1. Well, they're both 0, so we'll get 0. Otherwise, for this, we'll get 1, right? Because are either of them 1? Yes. Then same, of course, for this and also for 1 or 1. So it's kind of like the opposite in a way. I mean, this is obviously still going to be 0 in both cases, and this is going to be 1 in both cases, but it works very similarly to a logical OR operator, right? If either of these values are true, then we get true. And just to give you a bit of an example, if I had some random value like this, then you can see that the result would be something like that. In fact, the result would be that. I don't know why I said something like that. One thing you can do with these exercises, by the way, is if you really are kind of new to these operators, then feel free to actually try and do these on paper by yourself before I kind of give you the answers. It'll force you to like think a little bit and actually remember and learn how these operators work a lot better and a lot quicker. Okay, so what does this let me do in comparison to this whole bit masking thing? Well, the OR works kind of in the opposite way. We can use this AND, like in this case, to take away bits, right? So just to get rid of bits entirely. With OR, we can actually use it to add bits. So if we had this whole group of zeros here, right, that we just took them all away, and I actually wanted to add these bits back, I could OR those zeros with this kind of bit pattern, 10110, and I would get them back. Now in this particular example, I would also actually need to shift them left though, because you can see that in this case, this value doesn't start at the first kind of position. This is our first position, this is our least significant bit, but we need to start kind of writing these values in here. So let's actually do that. This will be a good example, I think. So this is the original value that I had over here. I'll stop drawing stuff on top of everything so that it's more clear. And we ANDed it by this, so now we're left with this. So with this specific value that we had, I'll write it out over here. How do I get back to the original value if I know that what I took away were these bits over here? Well, again, if I try to OR them by 10110, well, that wouldn't really be that useful to me, because obviously what that would do in this case is, well, these are all zeros, they remain zeros. But then here what would happen is I would change some of them to ones, and it would just become this, which is still not my original number. So what I have to do is actually take this number over here, this bit pattern, which I want to end up in this place, and first shift it left by, in this case, 4 places, right? 1, 2, 3, 4 would shift it from here to, and this is kind of the usefulness of using Photoshop here and not drawing on paper, I can literally move it over here, right? 4 places. That's how much I've moved it by. And so what I end up with is just zeros over here. And now if I OR these two values together, 101001101, then guess what? I'm left with my original value. So in summary, what would this look like if it was actual code and not just a drawing on a screen? We would write some code such as this. So int a, I'll say, is equal to this, which we know is 0101. Now I'll pretend that we're writing in binary here. If you ever want to write in binary directly in your C++ source code, you can actually do 0b and then the pattern that you want, right? So it's kind of similar to hexadecimal, how you could just put a little 0x and then write them in hexadecimal. You can do the same in, I think it's C++, like, I don't know what version onwards, but you should be able to do 0b and then whatever value you want. So if we have this a variable and we want it to turn into this, we'll create our little b variable here, which will be this value that we want to add back. So 10110. And by the way, this leading 0 is of course kind of useless. We can get rid of it if we want to. And then I'm simply going to take b and shift it left by 4 places. So I'll write some code like that. And then finally, our result, right, which I'll call c, will be a or b. And then this c variable is what this will be. This is our new c variable. And here is an actual C++ source code example if you want something that you can actually run yourself. The only kind of different thing I'm doing here is actually putting this final integer into a bit set of 9 bits. just so that I can actually see it printed in binary when I run my program. And the result of running this is this, which of course is my original value. So that is the bitwise AND and the bitwise OR. Now these two operators are used pretty often, to be honest. In terms of like bitwise operators and their uses, these are used pretty frequently. Now, bitwise XOR and NOT, they're not used as often. NOT is actually very useful with AND, because whilst the OR operator can actually set zeros to be 1, we can't ever set a 1 to be 0 using the OR operator, because if we OR it with 0, we'll just get 1. However, AND, obviously, if we want to set something to 0, we can just AND that bit with 0 and we'll get 0. So what we can actually do is combine the NOT operator with the AND operator to be able to toggle bits on and off. So here's an example of that. In this example that we had earlier, I was able to set this bit to 1, leave everything else as 0 in order to actually see the value of this specific bit. But what if I want to set that to 0? Well, if I know what bit I actually have, it's number 0, 1, 2, 3, 4, 5, we as humans can easily just build up a mask for that. So I could write 1, 1, 1, 0, that's the one I want to set to 0, and then 1, 1, 1, 1, 1, right? But how do we do that programmatically? Well, what we can do is still actually have this specific bit set to 1. So if we had like an enum with like some bit flags or whatever, then we would assume we would already have like a define for that specific bit. But if I take this value 0, 0, 0, 1, 0, 0, 0, 0, 0, and I bitwise NOT it, right? Then the value that I get is 1, 1, 1, 0, 1, 1, 1, 1, 1. And now what I can do is take this and AND it with this original variable here. And then every single bit will remain untouched except for this one, which will get set to 0, right? So in other words, if we take this original variable, this will change to 0. Everything else will stay at 1. And I'm able to do that by just simply knowing which bit it is that I want to toggle off and then inverting it, right? By using the bitwise NOT operator to just create this new variable, which has 1s everywhere except for this place. So that's kind of my real world example of NOT. That's where I've used it most often. And then XOR, in my experience, has mostly been used for like hashing. And we'll talk more about that in the next episode. But basically this exclusive OR is only going to return true if the bits you are comparing are different, right? So if you think about all the other operators we've got, they work for whether or not the bits are the same, right? So in other words, 0, 0 gives us 0, 0, 0 gives us 0 in both AND and OR. And then 0 and 1 gives us 0, 0 or 1 gives us 1. So we have a different kind of operator for whether or not we want to return a 0 or a 1 if the bits are different. AND will always return 0 if they're different, or will always return 1 if they're different. But we don't have something that will specifically give us a 1 if they are different, because obviously AND will give us a 1 if they're the same, or will give us a 1 if they're the same. I want something that gives me 0 if they're the same and 1 if they're different, and that's what XOR does. So 0 XOR 0 gives us 0 because they're not exclusive, they're the same. 0 XOR 1 gives me 1 because they're different. 1 XOR 0 gives me 1 because they're different. 1 XOR 1 gives me 0. So you can see that we have something that is quite different from the other operators. Specifically, it works kind of like an OR, except in this case, if they're the same, it gives me a 0. So it's useful to kind of flip bits. Now, what's kind of interesting and a little bit unique about this XOR operator is if you have a value such as this and you XOR it with itself, so if I had like int a equals, well, let's just say this, and then I did int b equals a XOR a, right? So I'm XORing it with itself. This will always give me 0. The reason is that obviously if we take 1101 and we XOR it with 1101, none of the bits are exclusive. They're all the same because it's the same exact value. So it will always return 0. So if you want a really cool way to set a variable to 0, you can just XOR it with itself. And the funny thing is, sometimes this is actually faster than setting a variable to 0 on some architectures, but like not really, so don't go ahead and actually do this. Please don't. Maybe it will be faster. And so that is our overview of the rest of these bitwise operators. Okay, so I hope you guys enjoyed this video. If you did, please don't forget to hit the like button in the description below. this YouTube thing's hard. Now that we've covered all of the Bitwise operators, the next real step is learning how to use them in practice. Next time, in the final episode of this kind of like Bitwise binary mini series, we're going to take a look at some real examples. However, if you've been using all of this kind of Bitwise stuff lately and you have some examples of your own to give, then please leave them in a comment section below. I think that'd be great for people who want to kind of move on from this video, but maybe don't know where to go and don't necessarily want to wait for the next one. But anyway, thank you guys for watching. Don't forget to click the link in the description to get your free trial of Skillshare Premium, and I will see you next time. Goodbye.